is over the properties of equalities. The objective, students will be able to use the algebraic properties of equality to make conclusions. So first, we're going to talk about all these algebraic qualities. And again, same as what I talked about in the last lesson, I just typed these up. So if I'm going too quickly, make sure you're pausing it, make sure you're catching up. So the first thing, A, B, and C are all real numbers. Every A, B, and C you see on here is real. We don't really have to worry about that. We don't deal a lot with imaginary numbers in this. So the addition property, if A is equal to B, then A plus C is equal to B plus C. So if you add the same thing to both of those, it's still going to be equal to each other. As you can imagine, the subtraction property is the same way. You're just subtracting. A minus C is equal to B minus C. Multiplication, huge surprise. If you multiply the same thing by both sides, it's still equal to each other. And division, if you divide both things by the same side. So if you divide both sides by the same thing. Sorry, dyslexia happens. So one thing you'll realize, and you maybe picked up on it when I was saying it, the place we use these most is when we're solving. So when we use this most when you solve and you cancel something on both sides. So the example, 3x plus 4 is equal to 25. When I subtract 4 from both sides, that's the subtraction property. We can subtract that from both sides and it's still going to be equal to each other. Now we use it in some other places you'll find when we go to the next couple slides, but that's where we use it most when we're talking about proofs. Then these other ones are a little bit harder to remember, but you just have to buckle down and memorize them. The reflexive property is A is equal to A. They're always, if you have something, it's always equal to itself. I know that sounds ridiculous, but it does come up sometimes. The symmetric property, A is equal to B, then B is also equal to A. It doesn't matter which way you write that, A is equal to B, and then the other way is still the same. B is also equal to A. It doesn't make any difference what order you put the equals. The transitive property is very similar to the law of syllogism. If A is equal to B, and then if B is equal to C, that means A has to be equal to C. If A and B are equal, that means they're the same thing. If B and C are equal, they're the same thing. So A and C have to be the same thing. And the substitution property is a little bit more wordy. A can be substituted for B in any equation or expression. So if A and B are equal to each other, anytime you see an A, you can put a B in there. Anytime you see a B, you can put an A in there. It's just normal substitution like we've done before. So for each statement below, what property was used to make the conclusion? Now, when we do this, a lot of the times you'll hear me say this, we want to say, what property did we do to this side that gave us this? So what property did we use to this that then gave us this side over here? So if ST is equal to TU, then TU is equal to ST. That is the symmetric property. Again, the order doesn't matter when it's equal to each other, and those would be line segments, but again, it still holds true. If A, then A is equal to A, that is the reflexive. Again, that should be a really easy one if you have it memorized. But again, it's a little bit harder because I know sometimes people see that and say, oh yeah, what is that? That one's a really easy one. But they can't think of it. You need to make sure you study and know that. Now, what I said earlier, I said, what do you do to this to get this side over here? That's what I'm talking about with this one. Anytime you see this, what am I doing to this ST is equal to 5 to get 2 plus ST is equal to 7? Well, you are adding 2 to it, so that's going to be the addition. Whoa, there's not a TH, unless you say it with a lisp. Now, we'll talk about that in a second, but now look at number 4. ST plus TU is equal to SU, and TU is equal to 4, so then ST plus 4 is equal to SU. That is the substitution. If you want to abbreviate this, do not abbreviate it to just sub, because is that substitution or is that subtraction? I can't tell. You need to make sure you put enough that I can tell. So if you leave it SUBST, I can live with that. I'm going to spell it out just to make sure. That's the substitution property. So looking back at number 3, what if you said, well, this is substitution because if ST is equal to 5, then I'm going to plug 5 into that, and then 2 plus 5 is 7. Honestly, if you put that, I will at least give you partial credit. I might give you full credit on that. But again, I'm asking, what are you doing to this 5 to get this place over here? Well, you're not subbing in 5 to this to get this answer. You're adding 2 to it. That's what you're adding. You're adding 2, or that's where you're putting into that. Over here, if you look at the difference, this if is just one little statement here, st is equal to 5. This one has everything. It has the little equation, and it has tu is equal to 4. So that's one way you can tell it's substitution, because they give you both of them. They give you a little expression, and they give you what something is equal to, so that way you can plug it in. Over here, they didn't give you that. They just gave you st is equal to 5. Now, that said, again, if you put substitution for this, I at least will give you partial credit. I'll maybe give you full credit. And honestly, if I don't give you full credit and I count you wrong, after the test, come and talk to me. And if you can tell me all that, then I'll give you credit. Because remember, I want to make sure that you understand the concept. And if you can argue that and tell me why you think it's substitution, that means you get the concept. If xt is equal to 5, then xt minus 1 is equal to 4. Again, it only gives you the xt is equal to 5, and then we are subtracting 1 from that, so that's subtraction. And again, also, if you think of, well, we add 1 to both of these to get xt is equal to 5, so you put addition. Again, if you put that, I'll probably count you wrong, but if you come up after the test and talk to me about that, I'll totally give you full points for that. Because again, you're letting me know you understand the concept, you just looked at it a different way. If LM is equal to 12, then 3 times LM is equal to 36. Again, if you put substitution, I kind of get it, but again, they only give us LM is equal to 12. They don't give us the full formula and something to plug in. So this is multiplication. Property. Number 7, if TU is equal to RS and RS is equal to MB, then TU is equal to MB. So TU is equal to RS and then RS is MB. It's kind of nice if you see, I know some people have done this where they cross out everything in the middle since RS are the same. So you have TU is equal to MB. If that's how you want to think about it, you can. But that's the transitive property. Now again, don't put the law of syllogism on this because we're looking for a property. I know it seems it's very similar, but it's not exactly the case. Number 8, if 3x is equal to 9, then x is equal to 3. So again, what are we doing to this side to get this answer? Well, we're dividing by 3, so that's the division. We spelled it completely wrong. Division property. And number 9, we have 4x plus 4 is equal to 12, then 4x is equal to 8. So we subtracted 4. What do we do this? To get this, we subtracted 4, so that's the subtraction property. So moving on from that, using the properties listed, complete the statements below. So we're looking at what property they're telling us, and then we're going to complete this if-then statement. So with the symmetric property, if AB is equal to YU, symmetric property means that YU is equal to AB. The order can flip-flop like that. The addition property, if AB is equal to 8, then AB plus 6 is 14. Again, you are saying, and again, honestly, with this one, it's hard because if you thought this was substitution because I plugged 8 into this one, I can see where you think that, and the good news is you'd still be right because 8 plus 6 is 14, so I can live with that. That's fine. I guess try not to think too hard about that. I'll try to be lenient with those. Reflexive property of equality. The measurement of angle ROP is equal to the measurement of angle ROP. Reflexive means it's equal to itself. Substitution property of equality. So we have LM is equal to 7, and then we have EF plus LM is equal to MP. So substitution, that's where we're subbing in that LM. And again, you might say, well, I did that with number 11. The good news is you still get the same answer. You still get the right answer if you do it that way. So this is EF plus LM is 7 equal to MP. Again, if you want to be finicky with this, you want to look, the reason it's substitution is the hypothesis includes what you sub in and the expression. Over here with addition, the hypothesis just included AB is equal to 8. So that's one of the ways you can tell a difference. But again, the good news is with this section, you're getting them all right, this part of the notes. Transitive property. If AB is equal to BC and BC is equal to ZY, again, you can kind of think since those are the same, we can kind of take them out if you want to think of it that way. But that means that AB is equal to ZY. Multiplication property. Measure of anglement ABC is 20, then 2 times, this would be the 20 is 40. Again, I know that looks a little bit like substitution. I get it. The good news is for this one, you would have gotten it right anyway. So this is what I like for the division property. When we looked at the multiplication and the addition property, this is how I like those to look. I think it's a little bit easier. If 5 times AB is equal to 45, then AB is equal to 9, and the reason is because we divided both sides by 5. And so that makes a lot more sense to me, and honestly, when we're doing proofs, that's what it looks a lot more like. But again, either way, you're still getting the answer for these parts. The subtraction property of equality, we have measurement of angle ZYA is 35, so measurement of angle ZYA minus 16 will be 35 minus 16 is 19. All right, moving on, we have a couple of proofs now that we're actually going to be doing. So when we do these proofs, so in this one, I didn't give you enough information. Sorry, it's on your notes, but it's not in the video. So the thing that I forgot that's on your notes but not in your video is this should say here at the top, given 10 minus 2x is equal to 3 times x minus 2 plus 4. So given that, prove x is equal to 12 over 5. So sorry, that should have been typed in there, but I'm going to have to re-record the whole video if I want to do that, so that's good enough. So on your notes, it should say given 10 minus 2x is equal to 3 times x minus 2 plus 4. Given that, prove that x is equal to 12 over 5. So the biggest thing is the first thing where they tell you this formula that I told us, that reason is the given. So in a proof, you're going to show how you solve this every single step, and over here you're going to write the reasons for those. So the reason I know that 10 minus 2x is equal to 3 times x minus 2 plus 4, I know that because it's given to us. And every single proof we do, the first step is given. I repeat, every single proof that we will ever do in this class, the first step is given. If you put given on the first step and I count you wrong, I promise you I will give you your points back because I'm telling you the first step is always given. That said, I will give you a heads up, the last step is never proof. Don't ever put proof for your last step. That is not a reason for anything. So now, I always start with given, and then I ask myself, so what did I do to get to this step? So what did I do from this step to get down to this next one? Well, it looks like I took this 3 and I distributed that. So that is a distribution step. So that is distribution. So I'm sure there's like a fancy name that's like the distribution property of equality or the distribution property for us. We know that's distribution. We can just say that's what we did. We just distribute. And if you just said distributed, that's fine. So then now, how did you go from that step we were just at? How did you go to this one down here? So if we look, we had, we took this -6 and 4, and we combined those to get a -2. So there's a couple different things you can put for this one. You can just say simplify if you want, because you just simplified. You could say substitution. And honestly, you could also, I would accept if you put addition, because you technically took -6 and added it to 4. But I like simplify. I think simplify is a lot easier. So then, again, how did we go from the step we were just at? How did we go to the next one? So it looks like we added 2 to both of these sides. Well, you added 2 to both sides, so that means that's the addition. Now, a lot of people get confused at what step they're writing these reasons for, and that's why I keep telling you, start at the step you were just at, and how did you get to the next step? And that's what you're putting for the reason for that next step. Again, you're saying, how did we get to that step? So this step right here, how did we get there? Well, we added 2x to both sides, added 2x. So that is addition. That's how we got to that step. Then how do we go from here to here? We divided by 5, divided by 5. That is division. And again, I should technically put the division property of equality, but I'm okay with you guys putting that. And last but not least, I said prove that 12x is equal to 12 over 5, and this is not that. It says 12 over 5 is equal to x. That's the difference. So how did I go from here to this next step? Well, I used the symmetric property. So that is how you do a proof, and it gets, I mean, you can have ones that are way easier than this, and you can have ones that are much, 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 much harder than this. But this is the basic proof where you have all your steps, all your solving is on the left, and all your reasons are on the right. We'll do a lot of them like this where it's fill in the blank. So this one, they give us the given, and even without reading this, I can put given, because I know the first step is always given in all these. I want you to prove that x is equal to 14. So what do we do first? We distributed that 3. That gave us the 6 plus 12, so that's distribution. Again, technically, the distribution property, but that's okay. So now we have 6x minus 12 is equal to 5x plus 2. How do we get to the next step? So how do we go from this one to this one down here? Let's see. I am subtracting 5x from both sides. So that is the subtraction. So then I have x minus 12 is equal to 2. So how do we go from this step? How do I get this next step? Well, I added 12. So now it is the adding property or addition, depending on how fancy you want to say it. You can also say it with a French accent. It makes you sound way more intelligent. It is addition. So same thing with the next one. I give you the given, and I tell you to prove that x is equal to negative 10 without you really even having to look for it. I know that first step is given. It always is. And again, it's because they give us that. That's what you're starting with. It looks like then we subtracted the 2x from both sides. So that means we have subtraction. Then it looks like we subtracted 8, so we have subtraction again. That's completely fine. And again, a lot of people get confused at which step you're justifying over here. Personally, I think it helps with start with the given, and then just each step you're writing that out. But again, you can always say, how are you justifying going to that step? How am I justifying getting to this next step? Well, I divided by 2. So how did I get here? I divided by 2, so that's division. Again, this last step is never proof. I know someone's going to do that. It happens all the time. You never have, the reason is never proof. That's like you coming up to me and saying, hey, how did I get a 55% on the test? And I just said, graded. How come I'm failing your class? Test. No, it doesn't work. We need more specifics than that. Now, this next one is called a 2-column proof, and we won't do a heck of a lot of these, but I want to show you this. This one, you have to do your own. So before, I was doing all the work for you, and you just had to fill in the reasons. This one, I want you to show me your work and tell me the reasons. Now, you might have different reasons than your neighbor. You might take 4 steps. Your neighbor might take 6 steps. It doesn't make any difference. We have our given, and we have our proof. So the first thing I do is I write out my given. 5x minus 4 is equal to 6, and the reason for that is given. Now, before I do my proof at all, this is what I want you guys to do. Over here off to the side, 5x minus 4 is equal to 6. Solve that problem. Before I do anything, I want you to solve that, and we better get x is equal to 2, unless I did something wrong, which is very possible. So first thing I do is I add 4 to both sides. So then, actually, let's do it this way. Add 4 to both sides. So then that gives me 5x is equal to 10. Then my next thing, I'm going to divide both sides by 5. That gives me x is equal to 2, and we're done because that's what we're looking for. So now go back to your work over here, and you're going to put all your steps. So my first step was 5x minus 4 is equal to 6. My second step ended up giving me 5x is equal to 10. My next step ended up giving me what I was trying to prove, x is equal to 2. Now go back and say, so how did I do that? Well, over here we added 4, so that means this step is addition, the addition property of equality. And then how did we go from this step down to here? Well, we divided. So that's the division property. So we can make these 2-column proofs. Honestly, a lot of people hate these, and I hate grading them. The good news is most of the other teachers also don't like these proofs, so you don't have to worry too much about them. But I really like, these are good proofs that get you thinking and get you wondering why you're doing things. And this is really where you can understand your algebra. And this is where I've had some students that are terrible at Algebra 1, and they get to geometry and they start doing these proofs and they're absolutely terrible at it. But eventually it starts getting to where it sticks and they know the reasoning why they're doing stuff, and they get way better at algebra because they know why they're doing every step that they're doing. So if you have any questions, make sure you're letting me know. And you can email me and call my office hours if you need to. Email is definitely preferential. You should email me. It works way better.